Come on, my dears, now we begin the exercise numericals. Kindly read the statement of first numerical in the exercise. Read it? Look. Here we are given 4 measured values of electrical resistances, correct? Let us show them by symbols A1, A2, A3 and A4. They are respectively 4.12, 4.08, 4.22, 4.14, that many ohm. SI unit of electrical resistance is ohm, okay? What is called actually electrical resistance, what is this SI unit, this everything will be taught to you in third semester, okay. At present you just remember the unit which is ohm and the symbol for ohm is this symbol, got it? Fine. Now in this experiment where one experimenter has measured 4 values of resistances, which are the different types of errors, that is what we have to find out, okay. Let us find out. First of all, we go for finding average value, that is A bar, in which you must divide the summation of given observations by number of observations, correct. Here we have taken 4 observations, so summation of 4 observations divided by 4, okay. A1 plus A2 plus A3 plus A4 divided by 4. Now this summation, if you find out from here, addition of all these values comes out to be 16.56, that divided by 4. This comes out to be 4.14, that many ohm, okay, fine. Now let us find out absolute errors in different observations independently. In the first observation, the absolute error is delta A1, which is A bar minus A1. A bar is 4.14 minus A1 is 4.12. Subtraction comes out to be 0.02 ohm. Absolute error in the second observation is delta A2, which is A bar minus A2. A bar is 4.14, A2 is 4.08. Subtraction comes out to be 0.06 ohm. Absolute error in third observation is delta A3, which is A bar minus A3. A bar is 4.14 minus A3 is 4.22. Subtraction comes out to be minus 0.08 ohm. Absolute error in the fourth observation is delta A4, which is A bar minus A4. A bar is 4.14 minus A4 is 4.14. Subtraction comes out to be 0, correct. Remember, the absolute error may be positive, may be negative, may be 0 also, correct. And now we go for finding average of absolute errors. Average absolute error, average absolute error. Now it is shown by symbol delta A bar, but now take care, you are supposed to make addition of moduluses of independent absolute errors. That summation should be divided by total number of observations. Come on, here it is mod of delta A1 plus mod of delta A2 plus mod of delta A3 plus mod of delta A4, that divided by 4. When you take modulus, you are supposed to convert negative value into positive value. Whichever value is from beginning positive, just leave it positive only. But if any absolute error is negative, you must take it with positive sign because you are taking now modulus, okay. Come on, take summation of all these values with positive sign, and that summation should be divided by total number of observations. Right now it is 4. This summation comes out to be 0.16, that divided by 4 comes out to be 0.04, that many ohm, okay. Now relative error or partial error or fractional error, it is delta A bar upon A bar, delta A bar upon A bar. Delta A bar is 0.04 divided by A bar is right now 4.14. This upon this comes out to be 0.0096, okay. Remember, this is the average value of absolute error which has the unit, but this is relative or partial or fractional error which does not have any unit, because it is resistance upon resistance. Resistance upon resistance will be not having any unit. Okay. Ratio of identical physical quantities will not have any unit. Okay. Fine. Now, what about percentage error? It is nothing but relative error multiplied by 100%. Relative error is delta A bar upon A bar, that multiplied by 100%. Now, this value has come out to be 0.0096 multiplied by 100%, it is 0.96 that many percentage, correct. Now, the sum is over here only, but let us express the final measurement of resistance in two different ways. First, in terms of average of absolute errors, secondly, in terms of percentage error. Okay, come on. Resistance, how would you write it first way? Come on, first of all, you should write down average value. Average value is 4.14 plus or minus average absolute error, and that has come out to be in this case 0.04 that many ohm, correct. Come on, second value of expressing the resistance is, first of all, write down average value, which is 4.14 ohm plus or minus percentage error. Percentage error is 0.96 that many percentage, correct, that many ohm, correct. 0.96% you will take of this value, and that much value you can add, you can subtract. When you add, it will give you maximum possible value, and when you subtract, it will give you minimum possible value. Got it? Fine. Kindly read now statement of second example in the exercise. Read it? Come on. We are given one cylinder for which the length is 4.00 plus or minus 0.01 that many centimeter. Radius of circular cross section is 0.250 plus or minus 0.001 that many centimeter. Mass of the cylinder is 6.25 plus or minus 0.01 that many gram. Symbol of gram is not gm, it is only small g. Take care. Now, we are asked to find out percentage error in the density of material of this cylinder. Let us find out. Density equals to mass upon volume, correct? Mass as it is. So, for volume of cylinder is concerned, you must have remembered by formula V equals to pi r square h. Instead of height h, you may take length L also, no problem. So, V equals to right now volume of cylinder, which is by formula pi r square h or pi r square L, correct? Fine. Now, when we write relative error in density rho, you can write it this way, delta rho upon rho, correct? Come on, from here relative error in mass, it is delta m upon m. Come on, for pi, because it is mathematical value, you are not supposed to write any error in that because it is a mathematical number, okay? We are supposed to write errors only in physical quantities. Pi is not a physical quantity, okay? Now, go for writing relative error in r square, but it is not r, it is r square. So, you know this power will become multiplier, correct? So, relative error in r square will be 2 times relative error in radius, correct? So, 2 into delta r upon r plus, come on, relative error in length, it is delta L upon L, correct? Remember, irrespective of any physical quantity appearing in the numerator or appearing in the denominator, every time you must add their relative errors in order to find out maximum relative error, okay? Fine. Now, delta m upon m, in the measurement of mass, this is delta m, this is m. So, delta m upon m means 0.01 upon 6.25 plus 2 times delta r upon r. In the measurement of radius, this is delta r, this is r. So, 0.001 divided by 0.250 plus delta L upon L. In the measurement of length, this is delta L, this is L. So, it is 0.01 upon 4.00, 0.01 upon 4.00, correct? Now, this comes out to be 0.0016 plus this comes out to be 0.008 plus this comes out to be 0.0025, and this addition comes out to be 0.0121. but now we want percentage error in the density. So, this relative error must be multiplied with 100%. So, this multiplied by with 100%, you can find out by multiplying with 100% here also. When you multiply this value by 100%, it will give you 1.21, that many percentage. Okay. So, in the present measurement, this much is the percentage error in the measurement of density of material of this given cylinder. Got it? Can we read now statement of number 3? Read it? Look. Here we are given one simple pendulum using which we are supposed to find out the percentage error in the measurement of gravitational acceleration of a given place. Let us find out. When the readings are taken using this simple pendulum, they found that length is expressed this way, 100 plus or minus 0.1, that many centimeter. Come on. Periodic time is expressed this way, 2 plus or minus 0.01, that many second. Now, in the theory of simple pendulum, in the dimensional analysis, we had obtained one formula for periodic time of simple pendulum, and that formula was T equals to 2 pi under root L upon G. Remembered? Now, just take squares on both the sides, then it will be T square equals to 4 pi square into L upon G. And now, find out G from here, it will be 4 pi square L upon T square. 4 pi square L upon T square. Now, find out relative error in G, that is delta G upon G, and that equals to this 4 pi square is a mathematical number. Come on, we don't have to write any error in this mathematical number, we are supposed to write error only for the physical quantities. Come on, write relative error in length, it is delta L upon L plus relative error in T square. But whenever there is a power, that power you should take as a multiplier, correct? Relative error in T square is nothing but 2 times relative error in periodic time T, correct? So, I am writing 2 times delta T upon T. Come on. Now, delta G upon G as it is, now it is delta L upon L. In the measurement of length, this is delta L, this is L. So, delta L upon L means 0.1 upon 100. 0.1 upon 100 plus 2 times as it is delta T upon T. In the measurement of periodic time, this is delta T, this is T. So, it is 0.01 upon 2, 0.01 upon 2, right. Now, simplify this right hand side, it comes out to be 0.011. Now, we want percentage error in G. For that, we must multiply this relative error by 100%. So, multiply here also by 100%, and when you do that, this will come out to be 1.1%, 1.1%. Okay. So, in the present measurement, the percentage error in the measurement of gravitational acceleration of a given place, the percentage error is 1.1%. Okay. Come on, my dears, kindly read this statement of 4th numerical in the exercise. Read it? Look. Here we are given one rectangular metallic sheet. Okay. Just for your better understanding, I have drawn that sheet in the figure. Look here. If this is that metallic sheet, because it has rectangular shape, it is a rectangular solid, I can show its 3 dimensions this way. This much measurement, let it be length shown by symbol L, correct? Then this much measurement will be its width or breadth shown by symbol B, correct? and this much measurement will be its thickness or height, and for height I have written small h. You may write small t for thickness, okay, no problem, whether you consider it as thickness or height, but so far its measurement is concerned, it is this much, okay, fine. Now this rectangular solid has totally 6 sides, 6 faces. Which 6 faces? Top, bottom, front, rear, right and left. I repeat, top, bottom, front, rear, right and left. I can show you those 6 faces. Look here. At present, you just consider this book as that metallic rectangular sheet. Okay? Then for this book, this much is its length. This much or this much is its length, correct? This much or this much is its breadth, correct? And this much or this much is its height, correct? Then it has totally 6 faces. Which 6 faces? I am showing you. Top, then similar face is there at the bottom, then this is the face at the front, this is the face on the rear side, correct, on this side. This is the face on the right hand side, similarly this is the face on the left hand side, correct. For the last time, come on, top, bottom, front, rear, right and left, correct. Now we are asked to find out total surface area of this metallic sheet, okay. Come on, if you consider top and bottom faces, then what will be surface area? Come on, length into breadth for this and similarly length into breadth for this. So it is 2 times L into B, 2 times L into B. That is what I have written here. Look, 2 times L into B, correct, fine. Then look here, this much is the breadth, this much is the height, correct. Come on, then B into H, it will give you this surface area. Similarly, this B into this H will give you this surface area, correct. So for this right and left faces, what will be total surface area? B into H plus B into H, totally 2 into B into H, correct. What about front and rear faces? For this front face, come on, its surface area will be this H into this L, correct. H into L will give you this surface area. Similarly, for this face also H into L, correct. So for the front side and for the rear side, what will be surface area? H into L plus H into L, that is 2HL. Here it is, 2HL, correct. Come on. When you add the surface areas of all the 6 faces, you will get total surface area of entire metallic sheet. Let it be capital A, correct. Now 2 I can take common. Inside the bracket it will be L into B plus B into H plus H into L. Length into breadth plus breadth into height plus height into length, correct. L into B, B into H, H into L. Simple, fine. Now these 2 as it is. What about length? They have given 4.234 meter, breadth 1.005 meter, plus this breadth is 1.005 meter, but now take care, this height or thickness they have given 2.01 centimeter. Convert it into meter, divide by 100, then it will be 0.0201, that many meter, correct. Plus, come on, height is 2.01 centimeter, divided by 100 is 0.0201, that many meter, 0.0201, that many meter, multiplied by length, they have given 4.234 meter, same value I have written here, okay. Now, this 2 as it is, simplification of this curly bracket, comes out to be, using calculator you can find it out, it is 4.3604739. That multiplied by 2 will give you 8.72094778, that many meters square, correct? Because all the measurements we had taken in meter, meter into meter, meter square will be SI unit for area, correct? But now we are given three measurements, length, breadth and height. And in length you can see there are 4 significant digits, in breadth also there are 4 significant digits, but in height or thickness there are 3 significant digits. So among given number of significant digits in given significant figures, the minimum is 3. So we must approximate final answer also up to 3 significant digits only. That's why what we do, we retain first 3 significant digits, okay? Then after this you can see this digit which is to be dropped down, and because the digit which is to be dropped is 0, which is less than 5, we can straightway drop it, and final answer we can approximate up to 3 significant digits in this form, 8.72, correct? That many meters square. But this is the approximate value, so I am writing here sign of nearly equal to, correct? When you will get nearly equal to, when you will get this value, when you make it rounded off, when you make it rounded off. That's why I am writing here in bracket rounded off, correct? So when you round off this figure up to 3 significant digits, your final answer would be 8.72 meters square. Simple. Now we are asked to find out total volume of this sheet, and that also up to proper number of significant digits. Let us find out. Come on, volume, I am just showing it by symbol capital V. For a rectangular solid, remember its volume is length into breadth into height. So here it is L into B into H, correct? Length is 4.234 meter, breadth is 1.005 meter, height is 2.01 centimeter, convert into meter, divide by 100, then it is 0.0201 meter. Here it is, correct? When you simplify, when you find out this multiplication using calculator, you will get it 0.0855289, that many meter cube, correct? But now among given number of significant digits in 3 given significant figures, the minimum number of significant digits is 3. So we must limit, we must approximate our final answer up to 3 significant digits only. And for that we just retain these first 3 significant digits. Then after this you can see the digit is 2, which is less than 5. You can just drop it straight away. Then final answer would be 0.0855, that many meter cube. But this is approximate value, so I am writing here sign of nearly equal to, correct? When you will get this approximate value, provided you are approximating your final answer to 3 significant digits only, correct? That is what you are making it rounded off, okay? So I am writing in bracket rounded off, got it? Fine. In textbook they have written 0.086 meter cube. It is wrong, because in 0.086 there will be only 2 significant digits, but here minimum number of significant digits is not 2, it is 3. So we must retain here 3 significant digits, got it? Fine. Now kindly read the statement of number 5. Read it? Look, we are given mathematical form of one result which is called Coulomb's law, about which you will study in detail in 3rd semester, but that equation is this: F equals to 1 upon 4 pi epsilon 0 Q1 Q2 upon R square. What are Q1 and Q2? They are 2 stationary point charges. What is R? It is distance between them. Epsilon 0 is called permittivity of vacuum, whose dimensional formula we have to find out. and F is Coulombian force or electric force. Okay, fine. Now for this physical quantity which we require dimensional formula, you just make it as a subject of equation. So when you do that, just find out epsilon 0 from here, transfer this F in the denominator. Okay, then is Q1 Q2 upon 4 pi F R square. Now because you want dimensional formula of this physical constant, you just put it in such a bracket. Okay, it is symbolic notation. Got it? And now you are supposed to write dimensional formula of all these quantities on right hand side. For charge, so many times I told you, it is current into time. So it is a raised to 1 t raised to 1. This is also charge, again a raised to 1 t raised to 1. Correct? 4 pi is a numerical value. We have to write down dimensional formula only for physical quantities. Okay, not for any mathematical number. Got it? Come on, for force it is m raised to 1 l raised to 1 t raised to minus 2. That is what you have repeated so many times. Now you must remember. Come on, r square, square of length. So I am writing l raised to 2. Correct? Now simplify. M raised to 1 going up will become m raised to minus 1. L raised to 1 plus 2, that is 3, going up will become L raised to minus 3. T raised to 1 plus 1, that is 2. 2 minus minus 2, that is t raised to 4. In the numerator, you will get t raised to 4. Correct? This a raised to 1 plus 1, that is 2. So altogether this gives you dimensional formula of permittivity of vacuum. Correct? Suppose it is permittivity of some other medium other than vacuum, then you may write here symbol only epsilon, only epsilon. Whether it is permittivity of a vacuum or permittivity of a given medium, irrespective of that, remember physical quantity remains same, it is permittivity. You will get same dimensional formula even if it is permittivity of medium other than vacuum. Okay, fine. Now read number 6. Read it? Look. Here in this example, we are given other 4 examples and whose dimensional validity we have to check whether given physical equation is dimensionally correct or false. That is what we have to find out. Okay? For that, you must count the total number of terms in a given physical equation. Whether it is on left side or it is on right side, irrespective of that, you please simply find out total number of terms in a given physical equation. Okay? And then you find out dimensional formula of all the terms. And if you find out that dimensional formula of all the terms are same, then and then only you have to pass the comment that given physical equation is dimensionally correct. But if all the terms do not have same dimensional formula, then you can just write final answer, given physical equation is dimensionally wrong. Okay? Come on, here we are given in the first section this physical equation, P equals to rho g h. Here there are 2 terms. This is one term on the left side, this is another term on the right side. Correct? Totally there are 2 terms. Let us find out dimensional formula of both the terms. Come on, P is here pressure. For pressure, you must have remembered m raised to 1, l raised to minus 1, t raised to minus 2. Same formula written here. Come on. Second term is rho g h, where rho is density, g is gravitational acceleration, h is height. Come on. For density, it is m raised to 1, l raised to minus 3. Here it is. For gravitational acceleration, you are supposed to write dimensional formula of acceleration, l raised to 1, t raised to minus 2. Here it is. Correct? What about height? You would write down for length, that is L raised to 1. Simplify, m raised to 1 as it is, L raised to minus 3 plus 2, that is minus 1, t raised to minus 2 as it is. You can see these 2 dimensional formula are same, and because in a given physical equation dimensional formula of all the terms are same, we can say given physical equation is dimensionally correct. Dimensionally correct. Correct? Fine. Now second section they given F into S equals to 1 by 2 mv square minus 1 by 2 mv0 square. Look, F is force, S is displacement, m is mass, v is final velocity, v0 is initial velocity. Okay. How many terms are there? 3 terms are there in this given physical equation. This is first term, this one is second term, this one is third term, correct? Terms are separated by the signs of plus or minus. Okay. You don't bother whether it is on left side or on the right side, you simply count total number of terms. Okay. Here there are 3. Come on, for this first term F into S, what is the dimensional formula? Come on. First of all, it is force. For force, you must have remembered m raised to 1, L raised to 1, T raised to minus 2. Same formula written here, multiply by displacement, and for that you have to write down for length. For length, it is L raised to 1. Here it is L raised to 1. So when you multiply these two, come on, m raised to 1, L raised to 1 plus 1, that is 2, T raised to minus 2. Correct? Come on. This is the second term, half mv square. 1 by 2 is a numerical number. You don't have to write anything for that. We are supposed to write physical quantities dimensional formula, not for the mathematical number. Okay, fine. Come on, for mass, it is m raised to 1. Here it is. For velocity, it is L raised to 1, T raised to minus 1. Here it is. Don't forget to make it squared. So it is m raised to 1, L raised to 1 into 2, that is 2. T raised to minus 1 into 2, that is minus 2. Correct? Come on, third term is half mv0 square. Come on, 1 by 2 is a numerical value. For mass, it is m raised to 1. v0 is initial velocity, but after all, it is velocity only, for which dimensional formula you know, L raised to 1, T raised to minus 1. Here it is. And its square. Come on, m raised to 1 as it is, L raised to 1 into 2, that is 2. T raised to minus 1 into 2, that is minus 2. Correct? Now, here also you can see all these 3 terms have same dimensional formula, same dimensional formula. That is why we have to write the final answer as given physical equation is dimensionally correct, dimensionally correct. Okay. Same thing I have written here, given physical equation is dimensionally correct. Okay. Fine. In the third section, they have given this physical equation, S equals to V0t plus 1 by 2 square of A into T. Here also there are 3 terms. Let us find out their dimensional formula one by one. First of all, for S, that is displacement, that is for length, L raised to 1, L raised to 1. Come on, this is the second term, V0 into T. For initial velocity, you know for velocity, L raised to 1, T raised to minus 1. Here it is. For time, it is T raised to 1, here it is. So it is L raised to 1 only, because T raised to minus 1 plus 1, T raised to 0, that is 1. Okay. What about third term? Third term is 1 by 2 into square of A into T. Come on, 1 by 2 is a numerical value. Come on, for acceleration, L raised to 1, T raised to minus 2. Here it is. For time, it is T raised to 1 and then whole square. Correct? Come on. Minus 2 plus 1, that is minus 1. L raised to 1 into 2, that is L raised to 2. T raised to minus 1 into 2, that is T raised to minus 2. T raised to minus 2. Correct? Now here, all these 3 dimensional formula are not same, though these 2 are same, but dimensional formula of third term is different than these 2. Correct? In short, all the terms do not have same dimensional formula. So what we have to write? Given physical equation is dimensionally wrong, okay. Same thing I have written here, given physical equation is dimensionally wrong. Okay. In the fourth section, they have given formula F equals to m into A into S upon T. Come on, there are only 2 terms. First term is F. For force, you know, m raised to 1, L raised to 1, T raised to minus 2. Same formula written here. What about second term? It is m into A into S upon T. For mass, everybody knows m raised to 1. For acceleration, L raised to 1, T raised to minus 2. Here it is. For S, that is displacement, that is for length, L raised to 1. Upon for time, T raised to 1. Correct? Simplify. M raised to 1 as it is. L raised to 1 plus 1, that is L raised to 2. T raised to minus 2 minus 1, that is T raised to minus 3. Correct? Here also, what we find? that these two dimensional formula are different. They are not same. They are not same. And so we can write final answer as given physical equation is dimensionally wrong. Dimensionally wrong. Okay. Same thing I have written here. Given physical equation is dimensionally wrong. Okay. Now sum number 7 is bit very long sum. There are 3 subsections in that. We will derive, final answer we will be getting for all the 3 sections. Okay. So we will solve all the 3 sections. Come on, let us see one by one. In sum number 7, see the first section. Read it? Look. If velocity of light in vacuum, gravitational acceleration on the surface of earth and atmospheric pressure are taken as fundamental units in a particular new unit system, then what will be unit of mass in that new unit system? That is what we have to find out. Okay? Now in such examples, for whichever physical quantity you require its a unit, that physical quantity you must write on left side. Okay. That is why I am writing small m here on the left side, because it's a unit we have to obtain in the new unit system. Okay. But now we are given 3 physical units as fundamental units. They are respectively velocity of light in vacuum, let it be shown by symbol small c, gravitational acceleration on the surface of earth, let it be shown by symbol small g, and atmospheric pressure, let it be shown by symbol capital P. Okay? One thing we know that this would depend on these 3 quantities, but with which power, how much power, that we do not know. That is why we just assume the powers to be respectively small a, small b and small d. You may write here small c, no problem, but that small c we have already used here. So let us go for assuming another symbol for that power, let it be small d. Okay. Give it equation number 1. Here values of a, b and d are real numbers, which those values we have to find out using dimensional analysis. Correct? Come on. A, B, D belong to R, whose values are to be found out using dimensional analysis. And here don't write any proportionality constant. Okay, fine. Now for mass, what is the dimensional formula? It is m raised to 1, L raised to 0, T raised to 0. I have written the same thing here, correct? What about velocity of light in vacuum? After all, it is velocity. For velocity, what is dimensional formula? L raised to 1, T raised to minus 1. Here it is, all raised to A. For gravitational acceleration, you have to write for acceleration, L raised to 1, T raised to minus 2. Here it is, all raised to B. For pressure, M raised to 1, L raised to minus 1, T raised to minus 2. Here it is, all raised to D. Correct? Come on. This part as it is. Come on, here M raised to 1 into D, that is M raised to D. Then L raised to 1 into A, that is A. 1 into B, that is B. Minus 1 into D, that is minus D. Correct? For time, T raised to minus 1 into A, that is minus A. Come on, T raised to minus 2 into B, that is minus 2B. T raised to minus 2 into D, that is minus 2D. Correct? Now just compare the powers of M, L and T on both the sides. Okay? Come on. When you compare powers of M on both the sides, you will get D equal to 1. Here it is, D equal to 1. Correct? When you compare powers of L, then A plus B minus D equals to 0. A plus B minus D equals to 0. But D is 1. Put D equal to 1 here. Correct? Transfer it. Then A plus B equal to 1. Correct? Compare powers of T on both the sides. Then you will get minus A minus 2B minus 2D equal to 0. Minus A minus 2B minus 2D equal to 0. Correct? Now, value of D is 1. value of D is 1, correct. This minus 2 when you transfer here will become plus 2. So minus A minus 2B equals to plus 2. But already we know A plus B equal to 1. A plus B equal to 1, correct. Let us add these two equations. Add these two equations, then minus A plus A will cancel. Then B minus 2B, that is minus B. When you add this to 1 plus 2, that is 3. When minus B equal to 3, then B equals to minus 3, correct. Put it back here. Come on, B equals to minus 3. B equals to minus 3. Transfer it. Then A equals to 4. A equals to 4. So we have found out all the three values A, B and D. A equals to 4, B equals to minus 3 and D equal to 1. Put all the three values in this equation number 1. Come on, start from here. M equals to, come on, C raised to A. C raised to A, look here. C raised to A, but A is how much? 4. A is 4. Come on, G raised to B. G raised to B, but B is minus 3. Come on, G raised to B, B is minus 3. P raised to D, but D is 1. So P raised to 1, correct. And now tell me, what is C? Given to you in the statement as velocity of light in vacuum, whose value they have mentioned 3 into 10 raised to 8 meter per second. Same value are written here, 3 into 10 raised to 8 meter per second. But don't forget this power. Power is 4, correct. Now G is acceleration due to gravity on the surface of earth, whose value they have given 10 meter per second square. Here it is 10 meter per second square, correct. And whole raised to minus 3. And capital P, that is atmospheric pressure, they have given 10 raised to 5 Newton upon meter square. Here it is 10 raised to 5, correct. And the power is 1, okay. Don't forget the powers, please. Come on, simplify. 3 raised to 4, it will be 81. How much? 81. And 10 raised to 8 fours are 32. Then 5 ones are 5. 32 plus 5, 37. 37 minus 3, that is 34. So it is 81 into 10 raised to 34, or the same value you may rewrite this way, 8.1 into 10 raised to 35, correct. 8.1 into 10 raised to 35, that many kilogram, correct. Because all other quantities we have used in SI unit system, then SI unit of mass is kilogram, small k, small g, don't put any full stop, got it. But remember, 1 kilogram is unit of mass in which system? In SI unit system. But in this presently considered new unit system, these many kilogram will be taken as a unit of mass, correct. These many kilogram equals to 1 unit mass in the newly chosen unit system, got it, fine. Now similarly, in the newly chosen unit system, we are supposed to find out unit of length also and unit of time also. Let us find out them also. Now in number 2, instead of mass, we are finding now new unit of length. That's why I am writing here L, correct. Right hand side you just keep as it is, but give equation number 2. But in equation number 2, values of A, B and D would be somewhat different. Let us find out. Write dimensional formula on both the sides. For length, m raised to 0, L raised to 1, T raised to 0, correct. For C, velocity of light in vacuum, after all it is some velocity only, L raised to 1, T raised to minus 1, all raised to A. For gravitational acceleration, come on, it is acceleration, L raised to 1, T raised to minus 2, all raised to B. For pressure, m raised to 1, L raised to minus 1, T raised to minus 2, here it is, all raised to D, correct. Now simplify, come on. This left hand side as it is, on right hand side, m raised to 1 into D, that is D, L raised to 1 into A, that is A, 1 into B, that is B, minus 1 into D, that is minus D, correct. What about T raised to minus 1 into A, that is minus A, minus 2 into B, that is minus 2B, minus 2 into D, that is minus 2D, got it. Now on both the sides, you just compare powers of M, L and T. Come on, when you compare powers of M, you will get D equal to 0, D equal to 0, here it is. Powers of L, A plus B minus D equal to 1, A plus B minus D equals to 1, but D is 0, put D equal to 0 here, correct. then you will get A plus B equal to 1. Okay, fine. When you compare powers of t, minus a minus 2b minus 2d equals to 0. But the value of d is 0, put it here, d is 0. So this part will be 0, then you will get minus a minus 2b equals to 0. But already you know one equation, a plus b equal to 1. Write it over here, a plus b equal to 1. Now add these two equations, minus a plus a will cancel, b minus 2b that is minus b, 1 plus 0 that is 1. If minus b equals to 1, then b equals to minus 1, b equals to minus 1. Put that b equal to minus 1 here, b equals to minus 1 and transfer this, then a will be 2, a will be 2, a equals to 2, b equals to minus 1, d equals to 0. Put all the three values in equation number 2. Start from here, L equals to, look here, L equals to c raised to a is 2, correct? Come on, g raised to b is minus 1, and p raised to d, but d is 0, correct? P raised to 0, that is 1. This is velocity of light in vacuum. What is the value they have given in the statement? 3 into 10 raised to 8 meter per second. Same value written here, it's a square. G, value of acceleration due to gravity on the surface of earth, they have given 10 meter per second square, whole raised to minus 1. P raised to 0 is 1. Now 3 square will be 9, 10 raised to 8 to the 16 minus 1, that is 10 raised to 15, that many meter, correct? In SI unit system, unit of length is 1 meter, but in this example, in the newly chosen unit system, this many meter will be equal to 1 unit of length. Okay, fine. Similarly, we are asked to find out new unit of time. So instead of L, now we should write T, correct? Right hand side as it is, give it equation number 3, but in this equation number 3, values of A, B and D would be somewhat different. Which values? That is what we have to find out. Write dimensional formula on both the sides. Come on, for time, it is m raised to 0, L raised to 0, T raised to 1. For velocity of light in vacuum, after all it is velocity, L raised to 1, T raised to minus 1, here it is, whole raised to A. For acceleration due to gravity, it is acceleration, L raised to 1, T raised to minus 2, here it is, whole raised to B. For pressure, m raised to 1, L raised to minus 1, T raised to minus 2, here it is, whole raised to D, correct? Simplify now. Left hand side as it is. Come on right hand side, m raised to 1 into d, that is d. Come on, L raised to 1 into a, that is a. L raised to 1 into b, that is b. And minus 1 into d, that is minus d. What about t raised to? T raised to minus 1 into a, that is minus a. Minus 2 into b, that is minus 2b. Minus 2 into d, that is minus 2d. Compare powers on both the sides with respect to mass, length and time. Come on. For mass, power is here, d, here it is 0, so d equals to 0, d equals to 0. For length, what is the power? A plus b minus d, and here it is 0. A plus b minus d equals to 0, but d equals to 0, put it here, d equals to 0. So a plus b equals to 0, fine. What about power of t here? Minus a minus 2b minus 2d, and that equals to 1, correct? But value of d is 0, put it here, d equals to 0. So this part is 0, you will get minus a minus 2b equals to 1. But you know one equation, come on, a plus b equal to 0, put it here, a plus b equal to 0. Add these two equations, minus a plus a will cancel, b minus 2b, that is minus b, 1 plus 0, that is 1. If minus b equals to 1, then b equals to minus 1, b equals to minus 1. Put that value over here, correct? When b is minus 1, transfer this, then you get a equal to 1. A equal to 1, b equals to minus 1 and d equals to 0. Put all the three values in equation number 3 here. Come on, start from here. T equals to, look, T equals to c raised to a, but a is 1, so c raised to 1, correct? G raised to b, but b is minus 1, so g raised to minus 1. And p raised to d, but d is 0, so p raised to 0, correct? Now p raised to 0 is 1, c is velocity of light in vacuum given to you in the statement 3 into 10 raised to 8 meter per second. Same value are written here, whole raised to 1. What about acceleration due to gravity on the surface of earth? They have given in the statement 10 meter per second square, whole raised to minus 1. Now 3 as it is, 10 raised to 8 into 1, that is 8, and this is 10 raised to minus 1. 10 raised to 8 minus 1, that is 10 raised to 7, that many second. In the SI unit system, 1 second is unit of time. But in this example, in the newly chosen unit system, the unit of time would be these many second. 3 into 10 raised to 7 second will be taken as 1 unit of time. Got it? Fine. Can you read now statement of number 8? Read it. Look, we are given one physical equation. It is V equals to A into T plus B upon T plus C plus V0. Here T is time and V is final velocity, V0 is initial velocity. What we are asked to find out? We are asked to find out the dimensional formula for small a, small b and small c, taking into consideration that given physical equation is dimensionally correct. Based upon that fact, we are supposed to find out dimensional formula of small a, small b, small c. Let us find out. When given physical equation is dimensionally correct, it means to say all the terms will have same dimensional formula. Then whatever is the dimensional formula of this first term, same will be dimensional formula of second term. So here I can write dimensional formula of A into T will be same as dimensional formula of V, correct? But V is final velocity. After all, it is velocity. Its dimensional formula is L raised to 1, T raised to minus 1, correct? But we want dimensional formula of only small a, so transfer this T in the denominator, correct? So this dimensional formula written as it is, but when you take this T in the denominator, its dimensional formula is T raised to 1. Take it up now. L raised to 1, T raised to minus 1, that is T raised to minus 2. So this much will be dimensional formula of small a. Got it? Come on. You know one thing, whenever any given physical equation is dimensionally correct, all the terms will have same dimensional formula. That is true. But remember one more thing, only identical physical quantities can be added, can be subtracted. Only identical physical quantities can be added, can be subtracted. Okay? So if you are adding C with T, then if T is time, C also must be time, then only you can make the addition. So one thing we know that this is time, correct? Because this is time, correct? Now addition of two values of time will give you new value of time, let it be T dash, let it be T dash, correct? So now tell me, the dimensional formula of this term should be same as dimensional formula of velocity. That's what I have written here. Dimensional formula of B upon T dash will be dimensional formula of velocity. For velocity it is L raised to 1, T raised to minus 1, correct? But we want dimensional formula of only small b, take this T dash over here. Come on, for small b, let us find out L raised to 1, T raised to minus 1 as it is. When you take this T dash here, it is some sort of time only. For time, what is dimensional formula? It is T raised to 1. So now it is L raised to 1 only, because T raised to minus 1 plus 1 will be T raised to 0, which is 1. Now, because you are adding C with T, and T is time, C also must be time. If C is time, its dimensional formula will be same as that of time, correct? For time, what is it? T raised to 1. So we were supposed to find out the dimensional formula of small a, small b, small c. That is what we have done, okay? Read number 9 now. Read it? Look. Whenever any body is allowed to fall freely from height h, its final velocity when it is about to touch the ground depends on gravitational acceleration of a given place and also depends on initial height. Okay? But at present we do not know with what power this physical quantity depends on these two. That is what we do not know. That is why we assume the powers to be small a, small b. Okay? Whose values we have to find out using dimensional analysis. Correct? So, suppose final velocity of body when it is about to touch the ground surface while falling from the initial height h is directly proportional to g raised to a, directly proportional to h raised to b. Okay? When same physical quantity depends on more than one physical quantities, then to write the result in a combined way, what we should write? We should write combinedly V proportional to this into this, correct? Product of these two right hand sides. Come on, V proportional to combinedly this into this, G raised to A, H raised to B. Remove sign of proportionality, put some proportionality constant. In textbook they have given symbol small k, so I am writing here small k. G raised to A, H raised to B as it is, give it equation number 1. Now what to do? Just write down dimensional formula on both the sides. For velocity it is m raised to 0, L raised to 1, T raised to minus 1. Small k is dimensionless proportionality constant. For gravitational acceleration you have to write for acceleration L raised to 1, T raised to minus 2. Here it is, whole raised to A, and H is height, which is some sort of length, so L raised to 1, whole raised to B. Come on, this left hand side as it is, correct? Now m, the term with m is not there, so I am writing m raised to 0. What about L? L raised to 1 into A, that is A, and 1 into B, that is B. Come on, T raised to minus 2 into A, T raised to minus 2A. Compare powers of T on both the sides. Power of T, here it is minus 2A, here it is minus 1. So minus 2A equals to minus 1, minus minus plus, A will be 1 by 2, A equals to 1 by 2. What about power of L? Here it is A plus B, here it is 1. So A plus B equals to 1, but value of A is 1 by 2, A is 1 by 2. Find out B, it will be 1 minus 1 by 2, that is 1 by 2, correct? So we have found out values of A and B, both of them are 1 by 2. Put them back in equation number 1 here, correct? V equals to small k, V equals to small k into G raised to A. What is A value? 1 by 2. What about H raised to B? B is also 1 by 2, B is also 1 by 2, correct? Come on, small k as it is, you can rewrite this step this way, G into H whole raised to 1 by 2, correct? Because you know A raised to M into B raised to M will be A into B whole raised to M, correct? Come on, small k as it is, whenever there is a power 1 by 2, it is as good as taking square root. So I can write this term in the square root sign, so under root of G into H. This is the last, that is final step in the answer, but practically when we find out value of small k, here it comes out to be under root 2. How much? Under root 2 in this case. So it will be under root 2 into under root of GH. Finally, altogether you can write under root of 2GH, under root of 2GH. Remember that formula, whenever any body is falling from height h, whenever that body is about to touch the ground surface, its final velocity is found to be V equals to under root of 2GH. Okay, fine. Here we are considering the case of free fall. Okay, fine. Kindly read now statement of number 10. Read it. Look, during explosion in the water at certain depth, there is formed one bubble, and because of energy released during the explosion, that bubble starts vibrating, starts performing some oscillatory motion, in which periodic time capital T is found to be depending on the pressure existing at the depth, is found to be depending on density of water, is found to be depending on energy released during explosion, correct? But at present we do not know the dependence, correct? I mean with which power this value depends on these three quantities that we do not know. That is why we assume the powers to be small a, small b, small c respectively. They are real numbers whose values we have to find out using dimensional analysis. Okay, let us find out. Remove sign of proportionality. You may put proportionality constant capital K, where capital K is dimensionless proportionality constant. Okay. Now write down dimensional formula on both the sides. Come on, for capital T, that is periodic time is some sort of time only. M raised to 0, L raised to 0, T raised to 1. Come on, for pressure, M raised to 1, L raised to minus 1, T raised to minus 2. Here it is. Whole raised to A. What about density? M raised to 1, L raised to minus 3. Here it is. Whole raised to B. What about energy? M raised to 1, L raised to 2, T raised to minus 2. Here it is. Whole raised to C. Correct? Simplify. Left hand side as it is. M raised to 1 into A, that is A. 1 into B, that is B. 1 into C, that is C. Correct? L raised to minus 1 into A, that is minus A. L raised to minus 3 into B, that is minus 3B. And 2 into C, that is 2C plus 2C. Come on, T raised to, here minus 2 into A, minus 2A. And here T raised to minus 2 into C, that is minus 2C. Correct? Now compare powers of M, L and T on both the sides. When you compare powers of M on both the sides, you will get A plus B plus C equals to 0. A plus B plus C equals to 0. Transfer this B on right hand side, it will be A plus C equals to minus of B. Fine. When you compare powers of L, here it is minus A minus 3B plus 2C, that equals to 0. Correct? Now just do one thing, this equation you may multiply by 3. If you multiply this equation by 3, you will get 3A plus 3B plus 3C, and 3 into 0 will be 0. Add these two equations, come on. 3A minus A, that is 2A. Come on, minus 3B plus 3B cancels. Come on, 2C plus 3C, that is 5C. 0 plus 0, that is 0. Now when you compare powers of T on both the sides, here it is minus 2A minus 2C, here it is 1. Minus 2A minus 2C equals to 1. Correct? Add this equation with this equation. If you do that, then minus 2A plus 2A will cancel. 5C minus 2C, that is 3C, and 1 plus 0, that is 1. Find out C from here. C will be 1 by 3. 1 by 3. Okay? Now you just multiply this equation by 2. If you multiply this equation by 2, you will get 2A plus 2C equals to minus 2B. And already you know this equation, minus 2A minus 2C equals to 1. Minus 2A minus 2C equals to 1. Just add these two equations. Minus 2A plus 2A will cancel. Come on, minus 2C plus 2C cancels. So I am writing 0 on left hand side. And here when you make addition, 1 minus 2B. 1 minus 2B. Correct? When you transfer minus 2B on left side, will become plus 2B. 2B equals to 1, then B equals to 1 by 2. B equals to 1 by 2. Correct? Now compare powers of T on both the sides. Then here it is minus 2A, here it is minus 2C, and here it is 1. Okay? So minus 2A minus 2C equals to 1. That is what we had done earlier. But now you know this relation between A, B and C. Use it. A plus C equals to minus of B. Here it is. A plus C equals to minus of B. Come on. A as it is. What about C? C you have found out it is 1 by 3. Put it here. C is 1 by 3. What about B? B is 1 by 2. Here it is. B is 1 by 2. Transfer this will become minus. So A will be minus 1 by 2 minus 1 by 3. Altogether it will be minus 5 by 6. Okay. In this sum we were supposed to find out the values of A, B and C. That is what we have already done. Come on. A is minus 5 by 6. B is 1 by 2. And C is 1 by 3. Now if further formula is to be derived, then you can just go further. Very simple it is. Put all the three values in this equation number 1. Start from here. T equals to K. T equals to K into, look here, P raised to A. P raised to A. Value of A is minus 5 by 6. Minus 5 by 6. Come on. Rho raised to B. B is 1 by 2. B is 1 by 2. Correct? Then come on. E raised to C. e raised to c, but c is 1 by 3, c is 1 by 3, correct. Now further in the statement, if they give value of proportionality constant, you are supposed to put that value over here, and then final formula you can just mention, okay. My dears, here all the exercise numericals are getting over, okay, and that is how we have finished whole chapter. We have covered all the theories very much in detail. Then after we had solved all the illustrations, then after all the MCQs, some of the short questions given in the exercise, and all the exercise numericals also, okay. I hope you must have understood in each and every article, okay. Thank you very much.